So, greetings and welcome to today's educational program. Postdoc research on applying leading indicators in cost of quality and in the quality space using technology monitoring and data gathering by Dr. Guillermo L. Ciudad. This is your moderator, Doug Wood, with ASQ's Quality Management Division. So today we have the distinct pleasure of hearing from Dr. Guillermo L. Ciudad. Please join me in welcoming him. Dr. Guillermo L. Ciudad is a Chilean-born international manufacturing supply chain experience professional. His international experience in quality includes working in the USA, Mexico, and home-based company locations in Canada, China, and Europe. This includes several suppliers and customers. He holds the following degrees: Doctor in Management and Organizational Leadership with specialization in Information Systems and Technology, Master of Arts in Organizational Management, and Bachelor of Science in Business Administration from the University of Phoenix. He also holds an Associate of Science in Industrial Electronics Engineering from INACAP, Chile. His doctoral dissertation research focused on three areas. The primary purpose was to explore if the Maglador industry in Reynosa was implementing continuous improvement methodologies, or CIMs. The second focus was to investigate if CIMs implementation related to organizational performance. And the third focus was to explore whether perceptions of CIMs implementation differed by level of management. So, without any further ado, it is my pleasure to introduce Dr. Guillermo L. Ciudad. Guillermo, the floor is yours.
Thank you very much for the introduction, Doug. First of all, I want to thank ASQ and the ASQ division, Grace and yourself for making this possible. And good afternoon, everyone. Good to see you here. I hope everybody is seeing the slide correctly and is hearing me well. If not, please let Doug know, send a message. Let's get started. I will go to the first slide, which is pretty much kind of shows what I have been doing for a while. In the areas that I'm focusing on, I am an ASQ virtual speaker. I joined the subcommittee and metrics for the Personal Care Product Council because I work for the cosmetic industry. I am a member of the National Leadership and Success, and I have taught in those universities, some in the U.S., some in Mexico. And currently, I am a doctoral dissertation coach volunteer. What that means is I help the doctors that have finished their academics part of the study and their dissertation to make it successful so they become doctors themselves. I do that as a volunteer. And I love what it is, the digital transformation that we have ongoing for, I'll say, really the past decade, that is getting better and better because technology is getting better and the price of that technology is going down. As you know, I've been very lucky that through the type of work that I do, I get to travel a lot. I've been in those countries where you see the start. I have learned a lot from those countries, the culture, the way they go about solving problems, and the way they communicate. As a South American, I love soccer. That takes pretty serious over there. Currently, I reside in Long Island, New York. In this slide, what I'm trying to do with this slide is trying to close the gap between the understanding of this presentation and the research, just to make sure that we're talking about the same definition or the same perspective. I will go through the applied research definition, the difference between leading and lagging indicators. I will talk about the research scope, and I will also clarify workflows to create leading indicators so that you could take that as a learning part of this presentation on how to go about creating your own leading indicators in your organization. The main areas of the applied research is the cost of quality, quality management, laboratory technology and analytic tools, and manufacturing lines technology and analytic tools. So I will cover all of these in one by one, so we make sure that we both are in the same page regarding the research. So the difference between applied research and academic research is the following. Applied research is designed to solve practical problems of the modern world rather than to acquire knowledge for knowledge's sake. So my degree, my doctoral degree is in applied research. In other words, I focus on the business side, on organizations, in domestic and international, and look at current theories, management theories, leadership theories, or technology, to see how they can apply, the keywords apply right away in the organization, take into account their organizational culture and so on. Main difference is apply the theory, tweak it, versus academic research where you do research for the future, for the longer term, not all the time, but more often than not. Here are the leading indicators by definition. The idea is that the leading indicator will show you if you're likely to achieve your objective. They look at the future. Leading indicator must be both predictive of achieving the main objective, and the team must have influence. Those two things are very important to understand in the application of leading indicators. So we're interested in predicting an outcome, but in order to be a good selected leading indicator, we must have both. It must be predictive, but we must have influence. If we don't have influence, we are not going to succeed. We can predict all we want, but without the influence on the leading indicator, it's not going to work. There is two types of leading indicators, generally speaking, where the team focuses on influencing the achieving of a weekly or bi-weekly result towards a predictive objective, and that's where it is important. The team feels that it can influence the outcome. And then the other one is tracking desired behaviors that will help the predictive objective. I can give you an example so it helps you to better understand that. Let's say in the case of root cause analysis, you want to have people you will have like people in your organization that know how to solve root causes. Well, a leading indicator could be how many people have received training on root cause analysis. And the other leading indicator is how the people that have received the training, how many are they participating in the resolution of root cause analysis. The outcome, ideally the outcome is the people that receive the training and they're actually participating, they will get the experience and get better and better in the resolution of the root cause analysis. Therefore, the outcome, the lagging indicator will be, the objective will be less CAPAs, less defects, less a lot of things, because now you're proactively achieving the goal of really resolving the root cause, because you have people that are trained and people that are participating. Hopefully that example helps you to illustrate the importance of a leading indicator versus a lagging indicator. These are most of the time, a lot of companies, including mine, use a lot of lagging indicators. The lagging indicators measure output that already has happened. So we normally measure profits, expenses, finished good reject, customer complaint. So we are really looking at these KPIs, the key performance indicators, when they're already happened. So they already happened. We look at what went wrong, and we try to look and see if we can fix that. And you can see it's like some people have called it like looking in the rear view mirror, because you're really looking for something that already happened. Hence my interest on really understanding the application of the leading indicators, not only in my industry, but the industry that you are representing, to see how many are they using it, how do you figure it out how to use it, or you are thinking about it. Let's talk a little bit about the research that I'm going to do, hopefully with your help. The scope of this applied research is to understand the gap among the different manufacturing industries on the application of leading indicators, where in the quality area, in the cost of quality, technology space such as laboratory, the laboratory you normally have an electronic instrument, and on the assembly lines with the industrial automation. here's the interesting part, and it's important that you understand this part. If there is enough quantity for statistical analysis of responses to the survey industry that are actually using leading indicators, what I will do is to test if there is a statistical relationship between leading indicators and organizational performance. The caveat is that if there is not enough quantity of industry that are using it, I cannot really do that because that will not be statistical. No proof. I cannot prove it statistical because it's not enough samples of size of the industry that are using it. So I will not be able to do, and I will not do something that is wrong. So the other objective that I am pursuing is to create a baseline at the beginning of the 2030 decade. So we are at the beginning of this decade. It will be interesting to see the difference between companies that are talking about using leading indicators and they have a plan, or they've been strategizing about it, versus the companies or organizations that are actually using it today, hence the applied research emphasis. I want to know, I'm not interested to know in companies that are thinking about it or they will think about it in the next couple of years. I want to know how many are they using it today. And that will be part of the establishing the baseline at the beginning of this decade. The reason for that is if we had a good sampling size, we can use it to make management decisions or open the door or leave the door open for future researchers interested in the subject, let's say 5 years from now, to expand and apply the knowledge acquired. So those researchers, new researchers, or even myself, in 2025, I look and I do a similar research and I compare to this one and say, yes, we have moved, we have advanced 30%, 20%, depending on the industries that we pull in on the survey. Let's say cosmetic industry, medical devices, or any other industry that we are going to identify in the survey. All right, so now what I'm going to do is to close the gap on the definition of a cost of quality. This definition and the model I got it from ASQ, which is the one that we're using in our company. So cost of quality is defined as the methodology that allows an organization to determine the extent to which its resources are used for activity that prevent poor quality, that appraise the quality of the organization, products or services, and then result from internal and external failure. I will clarify that in the next slide, where I will show you the model, and it will be hopefully will be much easier to understand than the definition. Here is the model. The cost of quality is combined. It's a combination of cost of poor quality plus cost of good quality. So the two of them is the total cost of quality. Underneath of the cost of poor quality, we have internal failure costs and external failure costs. Underneath of the cost of good quality, we have appraisal costs and prevention costs. Below those blocks, you see the kind of brief definition of what the internal costs are. For example, are costs associated with defects found before the customer receives the product. External costs are costs associated with defects found after the customer receives the product or service. Normally, the external costs are much higher because not only it's about money that you know, between the manufacturing of the product, distribution of the product, get it to the consumer or the customer, however you want to call it, and then the consumer, rejects it for you. Nowadays, we have not just to worry about costs in dollars or euros, but we have to worry about the cost of using social media, where they, you create a video, put it on YouTube or Facebook, and say, we found this product with this failure, it belongs to Estée Lauder, and we think that it's not good. And that's when you get to that point, the costs will be tremendous on the loss of credibility for the brand. and the fact that now you don't know how many people are going to use their video. So that could be a tremendous cost, or the cost of recall. So you have to be, you need to have really good system to get feedback from the consumer or the customer, so you fully understand what is the vision of the consumer or customer on your product and your brand in many ways. So be careful with the external failure costs. It's not just money that you worry about. You're worried about exposure on social media. And the cost of good quality, having good quality has a cost, despite of what they say about zero cost. That's, I'm not arguing against that. I'm arguing that it's a cost that is necessary to keep with regulatory compliance and the FDA in our case, and also protect the brand name and realize that when the consumer buy our brand, they're buying something good quality. They're paying good money, but they're buying something good. So in order to achieve that, we have appraisal costs. Those are costs incurred to determine the degree of conformance to quality requirements. And prevention costs are costs incurred to keep failure and appraisal costs to a minimum. Normally, what I've seen in the past in a program of cost of quality, a lot of companies worry about the internal failure costs. Some companies worry about external failure costs. Very few companies realize that there is a cost of good quality in appraisal costs and prevention costs. I'm not saying that you should reduce those costs right away, but as you're getting better here and here, there are chances, as long as you comply with regulatory compliance, is to start improving these costs either by adding technology to it or better trend analysis and kind of use predictive statistics. So, but normally a lot of companies work here, few in here, and very few realize there are opportunities in these two buckets. Hopefully that kind of clarify the cost of quality model. I'm also going to give you some real examples of external failure costs. I'm not going to read all of them, but you can you read rework, material rejects, material losses and control. Those are internal failures that normally happen within the four walls of the factory or even in distribution sometimes. And here are the ones that I am worried the most. External costs. I do not want the consumer or customer, however you call it, to get problems. And the worst are warranty claims. They can skyrocket, or if you have a recall, I don't have to tell you about the importance of not getting recalls. You will probably come from the quality background. You will know that that's definitely known already. And here are the other two buckets of the cost of good quality: appraisal costs, inspection tests, special tests, measurement equipment expenses, and prevention costs. Supplier review, supplier rating, operation process validation. Those are, I'm not saying they're not necessary, but they are prevention costs. I'll leave it there so you have a chance to see it a little bit. Because from here, you not only can see what are they, but you can start thinking about what are possible opportunities for leading indicators, working with a supplier, working within the factory to be able to get an alert before the problem really happens. In this particular slide, this is kind of heads up for you that I'm going to talk about technology, not in the media slide, but in the next slide, I'm going to talk about how to use technology in laboratory and also with the manufacturing lines. What is important is, and I think all of us have been going through this transformation, especially now with the COVID, and now we are using technology just not only to do data collection, but to communicate and to get things done. So the digital transformation is disrupting everything faster and faster, and it continues moving ahead. The major cause of digital disruption is the rapid advancement of technology and globalization. I can have meetings now with my team in Europe or in the APAC region or in Canada, or all of them together in one Zoom or Teams or WebEx in this case, but you can do that, which allow new business models to be produced at an ever-increasing rate and with rapidly declining costs. So these are important. The digital transformation is allowing us to have new business models, to develop new business models, and also use the ever-increasing rate and the fact that technology is declining costs. Imagine in the COVID year if we didn't have Amazon already, set up for using technology for ordering and delivering. Let's say Domino's Pizza has been in the business of delivering forever. It just got better. There were some organizations that, because of their business model, they were already set up for that, and that they maximize it in this moment. I don't have any stock in Domino's or Amazon, just in case. This is an area that I put in here, so if people are interested in to say, all right, I kind of started understanding leading indicators, I would like to figure out how to use them. These are workflows, and I put the regular, since we're in a quality world conversation right now, here are in the bottom are the definition: critical to quality, critical to delivery, and critical to cost. Those are three areas that normally we mean quality, but the organization works in improvement. So in this workflow, remember when I talked about the importance on the leading indicators is to have a team that has influence on the input variable. We need to focus in a few of those and track them. And also we need to identify the desired behavior that we want to be displayed to achieve that particular leading indicator. And what we have to do is maintain the discipline, continue doing it, collect the data, do trend analysis, and sustain to see the relationship between the leading indicator and the objective. If the objective is critical to quality, we can, as an example, we can start looking at the defects rate, for example, that you had the last quarter, and do a Pareto chart and identify your main hitters, and then do an analysis, work with engineering or whoever it is you need to work with, and figure out what could be the main drivers in here that will prevent these defects from happening. I'm not saying it's easy, and that's why leading indicators are not widely used, because it's much easier to use lagging indicators than leading indicators. But if you start thinking about how to use leading indicators, your objectives will skyrocket because you now have influence on them. You're keeping the focus, you're tracking them, and you are creating the desired behavior. As an example, remember when I said at the beginning that if you have people that receive the training in root cause analysis, and you're tracking that they're actually participating in teams of root cause analysis and they are resolving problems and they see it, your objective of defects reduction, consumer satisfaction, on-time delivery, all of those will start moving in the right direction. Not because you're just tracking the lagging indicator, you are actually influencing the outcome. The same thing happens on this workflow from critical to delivery. Because the consumer wants a good quality product, delivered on time at the right cost, right? That's why I put those three main ones. I'm sure there are other ones on new product development, et cetera, but I only have 45 minutes, so I decided to put these ones in there so you can get the idea if you want to develop some leading indicators in your organization. You at least have an idea how to go about it. I'm going to leave it in there for a second so you can see the workflow. Also, I encourage you to think system thinking. don't think just in a particular subsystem of system thinking. As an example, we just about all of us drive a car, right? The car itself is a system. It's a whole system. Within the car, you have the cooling subsystem. They got the brake subsystem. Oh, they got a lot of subsystems in their air conditioning subsystem, but they're all linked together, right? So you have to start thinking, system thinking as a big item, and then start looking into it to see in those areas where you can actually create leading indicators, because when the subsystem interact with the rest of the system, make a big difference. The other area that I will be interested in looking at if other companies are using leading indicators is quality management. You know, on the left you have quality management, quality assurance, quality control. We all know about the PDACs loop. Some companies are ISO certified. In the quality management system, we have drivers. We have customer focus, quality objectives, resources, and processes. Those in general, they feed the enablers. The enablers of that are continuous improvement, the CI groups and industrial engineering, or some people have R&D or some areas. And the all important is database analytics. I am a big proponent of not just collecting data. I've seen a lot of organizations, they're really good at collecting data. They're either so-so or bad about analytics. They don't analyze the data. They don't look at trends. They don't poke inside. You know, there's some gold mine of data that they could be mining and finding out what really is happening to predict outcome, to predict, let's say, or help the customer satisfaction. So look at your organization, please, and see what are they doing. Are they collecting data and find out what's the ratio between collecting data base versus how many people are actually doing data analysis, and more important, once they do the analysis, what do they do with it? The axiom that I follow is data, information, knowledge. Always question the data. That's your foundation. If the data is organized and it has been taken correctly, then you can build information. Sometimes I go into a conference room where they're presenting a nice presentation, beautiful bars and special effects and so on and so forth. That's information. But then I ask where did the data came from? And seldom I get a good solid answer. And that's when, then what happened, if I didn't ask that question, the moment, remember the pyramid, right? Data, information, knowledge. When it becomes knowledge, when the people in the room decide to use the information, they believe it, and they make a decision on it. They call it now. It becomes knowledge because people believe in it, and they make decisions, and then we hope that it was the right decision based on the information. But if we don't question the data, I don't care how beautiful that chart is, it's just wrong information. And if somebody in that room doesn't question the data, it's going to make the wrong decision. And that's going to affect the business, and going to affect people, and going to affect a lot of things. So please, if you take something from this presentation regarding leading indicators, focus on questioning the data always. In a nice way. You don't have to be mean or anything like that, but you really need to know where the data came from to make a beautiful chart. All right, so now we're going to talk about laboratory technology and analytics tools. So let's say we have our laboratory, we do all kinds of testing in the cosmetic industry. We do a lot of testing to protect, let's say in the skincare, we don't want any lotion, cream, or anything that go into your skin to harm you. So we make sure of all kinds of testing. But we don't only test it, we use analytics to see the trends and what are we doing. What I want you to think about is when you get raw materials from the suppliers or components, they normally, the supplier, I'm not saying all of them, but normally they say, hey, we meet your specs, therefore it passed, here it is. Well, it's hard to work with that on leading indicator unless, let's see this normal distribution curves in here, and the note that I made in here, understand the location and variation of the histogram in relation to the specification tolerances, and look for leading indicator opportunity, not just in pass or fail. Let me give you an example that hopefully helps you to understand what I'm trying to say. If we receive raw material in our business, we receive a lot of different raw materials that we mix, we compound it to make a cream, to make a lotion, whatever it is we're making. So if the suppliers send us a raw material that it always is in spec, but they don't tell us that they are using the entire spec. Let's say we're looking at the red curve as closer to the end of the spec as we can be. So it's using most of the spec. So whatever something happen or interact with another component, it might get out of spec and create all kinds of problems for us. But if we don't understand that, or we don't trend the data and we don't do a data analysis, we are not going to be able to see where the problem came from, because the supplier is going to say, hey, I sent it to you in a spec. So what we do, we make a histogram and we look at it where really is coming. Is it coming in the center with a very tight variation, really good sigma, the same thing here, or is it this side of the spec? And depending upon what is good for us versus based on the trend analysis, we can ask as a leading indicator to the supplier, hey, could you position the mean, let's say right here in this part of the spec with a tighter deviation? When we receive like that, we will not have problems in the other one. That's one example of using technology and also using analytical tools to start creating leading indicators or possible leading indicators. That's just one example that I can think of, and that you can do that in another labs in another industry. I'm sure that the engineers or the lab engineers have time or have experience. I will say no time, but have experience to see opportunities where to improve. In the end, you can use the same workflow to start imagining possibilities for leading indicators that affect, let's say, critical to quality or critical to delivery, whatever the case may be. Hopefully with that example, you get a better understanding of what I was trying to say with this situation. Technology and analytical tools, and of course you have to have the people with the capability to understand how to do the analytics. Sometimes you have the technology, we might have the software, but the person that is there that doesn't have the time or doesn't know how to do the analytics. That's one thing that could happen. Let's look at the manufacturing lines technology. It's a lot of, especially the new modern manufacturing lines, a lot of automation, a lot of integration of a lot of things in there. But you can use the same principle as an example. You know, you can use tolerance. You can have sensors that can measure distance. You can measure levels of lotion in my industry. In other industry, you can measure all kinds of. You can measure temperature, depending on what is critical to quality for you, or critical to cost. It depends on how you want to look at it. But it's there. The other thing that's interesting is just to make you familiar with this term, or some of you might already be familiar, but I'm trying to close the gap on the understanding of the research. The Internet of Things describes a network of physical objects, things that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the Internet. So, in other words, there are sensors and other technologies that now they're monitoring things, and they're sending the data to a central connection where there is a software that allows you to do analytics, to understand what is happening in that particular area where the sensor is positioned, and it's comparing to, let's say, manufacturing specification, and you can tell if it's working within the range or not, or it might affect certain critical to quality characteristics that you have defined, or it might affect the shutdown of the line, depending. On the double IoT in manufacturing, what it is, industrial Internet of Things, refer to the extension and use of the Internet of Things in industrial sector. In other words, it's the concept of Internet of Things, but now applying to industrial. To, let's say in our case, or in my case, is the manufacturing lines with a strong focus on machine-to-machine communication. So you have, sometimes you have substations that are put together in a big automation line that are integrated. So they talk to each other. We can collect big data and machine learning. The double IoT enables industry and enterprises to have better efficiency and reliability in the operation. There are tremendous opportunity and double IoT to look at opportunities for leading indicators. You see in the bottom of the slide, all of these are sensors or technology that can sense or measure or whatever it is you're trying to do. The beauty of the sensors nowadays is they communicate either Wi-Fi or Bluetooth. What that means is that you don't necessarily have to run the wiring in the entire equipment machine, or you have to stop the machine, run the wiring. That's equipment downtime. That creates a lot of problems. This new, well, that's not really new. They've been in there for a while now. All you have to do, understand the application, match it up with what you want to do, and then you bring either a Bluetooth or Wi-Fi communicator that communicates with your central software package that do analytics, and there you go. So it doesn't take that much to implement, because it's a matter of finding the right one, the right application, put it in the line or the motor that you want to measure. Like these ones here, you have 3 of them doing something. Like this one measure temperature. Let's say I want to measure the temperature of a servo motor that is important for an application, let's say torque. And the servo motor is designed to work between, let's say, 75 to 100 degrees Fahrenheit. And under those temperatures, it works perfect. But all of a sudden, your monitor that is telling you that temperature has increased and it's getting to the edge of 75. So either you have to find out why it's increasing, either high current is causing that, or the motor is going bad. So you look at past behavior in the data versus this one, and you can decide that before the motor goes down, in a planned maintenance, you can replace that motor before it shuts down the line. Imagine how much that saves from equipment downtime and the possibility of affecting delivery to the consumer. So that's tremendous. And that will be a leading indicator right there compared to the specification. That's just one example of things that you can do nowadays. This is not future. This is you can do nowadays with the right support, engineering support, technical support that allows you to do that. But there's a tremendous opportunity in these areas to put leading indicators. Hopefully, with that example, I help you to understand the application, or maybe some of you already are doing this. I just don't know, but I want to make sure I set the baseline. Here is the actual research. I created a digital survey that actually asks you for trying to get a baseline on where everybody is on this. So this particular screen is a screenshot of one of the pages of the survey, which talks about the organization main initiatives. So I'm trying to see how we're doing it from a maturity level. Basic level of maturity implementation in the organization, proficient level, advanced level, or not applicable. I put in this, these are the definitions of what is the basic level, the proficient level, and advanced level, and I'm going to include this definition in the survey to make sure that it's clear what I was asking. So in this particular case, using leading indicators as key performance indicators, you're either could be a basic, you can be proficient, or you can be ongoing cost of quality program. Let's say you're proficient. Data collection with digital tools in manufacturing, let's say you are advanced level, you're doing that. Using data acquisition and testing lab, let's say you're proficient. Data analytics and testing lab, actually, I should say data analytics and testing lab, but also data analytics in manufacturing. That's also could be basic or not. Do you have a QS, a nice house and ISO system in place for management? Do you have lean manufacturing? So what I'm trying to gauge is in the state of the industry, not only on lean indicators, but systems implementation that tells me the degree of maturity on compliance, either regulatory compliance or management of a quality system. Or let's say if you have lean manufacturing, you are trying to improve your waste reduction, variability reduction, and trying to get a product out of the door without creating a lot of work in process. Here are questions regarding the cost of quality. Is a Likert scale, strongly agree, disagree? So leadership commitment and active involvement of senior leadership have allowed the company to maintain an effective cost of quality, or you either disagree, neutral, whatever it is that you're going to respond. Also gives me an idea, or will give us an idea of where we are in the industry with a cost of quality program. I started with leadership because some of you, I don't know if you heard the conversation with that at the beginning. Without leadership involvement or without leadership understanding of different programs, it's very hard to get things done. So it's important the leadership commitment exists, but not only commitment, but they understand the tools that they are using or why they're using it. And the cost of quality, in my view, through experience, the finance professional meets at least once a month. What I'm trying to find out here is other companies in their cost of quality program, if they have it implemented, are they well integrated with the finance professional? Having finance involved from the beginning, it gives tremendous credibility to the cost improvements or cost savings, whatever the case may be, because finance has been there from the beginning, and when we have to show the improvements and costs or reduction of rejects or anything like that, we don't have to convince finance. Somebody from finance that is in the team is already talking the language of finance and have been very involved in the decision making from the beginning, either accepting what the claims are in dollar from the beginning or rejecting that that's not true, that because according to accounting principles and only it's only 50% true, but at least we go from a very well-founded base into a cost of quality program. And here is an area where I want to call quality management. Let's say leading indicators are used to predict trend supply performance. This the 5S system is used on a leading indicator of desired behavior. Remember at the beginning in the definition of leading indicators, it was about influence, but also about behavior. The 5S system, the guys who are familiar with the lean concept, 5S is very important in there. And what it is, it really is a behavior indicator. Are the people organized? Are the people putting the things in the right place? Is clean? Is less clutter? And that system is checked every day almost, and everybody participates. But that really is a behavior, a desired behavior, which at the end is a leading indicator because it needs you to do things better. Don't waste time looking for tools or et cetera, et cetera. There are companies that use statistical process control, and some of them without realizing that really is a leading indicator. And they normally is used on CTQ, right? Critical to quality. I gave the example of training the personnel in root cause and then participating. I don't know how I'm doing with time, Doug, but
We're running a little long, but I think it's fine. We'll have questions after the top of the hour. Go ahead.
Okay, and manufacturing line technology analytics. I think on the prior slide, I kind of told you what I was interested in, the utilization of technology, sensors nowadays easy to install, and identifying a leading indicator that you can put those sensors in the line, look at the data they're generating, look at the trends, and do the analytics and prevent objectives from not being fulfilled because something happened. And here is the laboratory technology. I gave you an example. And here is I think is the last slide on the survey. It's important for you to understand, for me to let you know why I put this caveat in red. Please respond to the items below only if your organization uses leading indicators consistently during the year. Since I am interested in companies that are using leading indicators, I know most of us are using lagging indicators, but I'm interested in the ones that are using leading indicators. If your company happens to be one that uses leading indicators during the year 2020, I want to see if there's any relationship, statistical relationship, between companies that use leading indicator and they see an increase in sales dollars or decrease or no change, new product successful launch ratio, and so on and so forth. So I'm comparing leading indicator with lagging indicators of performance at the end of the day. But if you are not using leading indicators, please leave this empty because it's not going. I cannot do a relationship, statistical relationship comparison because there's going to be noise because most of the company will use lagging indicators. So if you're using lagging indicators, but at least you're using leading indicators through the year, go ahead and answer it. And this is it. Thank you very much for attending the webinar and listening to the presentation. I would like to recommend to you a book that I always carry on my side. It's called The 4 Disciplines of Execution. You see the authors in there, and the second discipline talks a lot about leading indicators. Third discipline talks about dashboards. So it will be a good guideline for you to look at it and understand why I'm so interested in it and how can you apply. Go ahead, Doug, it's yours now.
Okay, yeah, we have had a couple of questions here. I want to kind of go over them. So we'll do a few. First of all, one question from Orlando. It says, leading indicators and OKRs have the same purpose, question mark. OKRs, I'm trying to understand that acronym. Do you know what that is?
No, I don't remember OKRs, unfortunately.
Okay, Orlando, if you can put something in chat to explain OKRs, that would help us. He also asked another question. He said, could you mention benchmarking in terms of supplier management digitalization? I suppose from the standpoint of whether benchmarking can be used for as a leading indicator of supplier management.
It can. It really depends on how you describe it, how you define it. What is going to be your lagging indicator? In other words, what is the objective of having that benchmark? If that's well defined, indeed you can use it. It really is. That's one of the issues with leading indicators. How you define it and how it makes sense to you, it can be used. But if you don't define it correctly, it really is a lag indicator in disguise. I can give you an example. Let's say a water company wants to increase their water production. So the manager could say, okay, I'm going to measure the water production every 2 weeks. Well, that's just really a lagging indicator. Oh, well, I'm going to measure it every week. Still a lagging indicator. What about if I measure the resources available in the 3 shifts that I have? Some of the shifts don't have enough people. Therefore, you can't produce one. What about my equipment uptime or downtime? If the equipment that makes the water is down most of the time or 70% of the time, I don't care if you measure every week or every day, it's still a lagging indicator. But if you measure how can you improve the manning of the different shifts to a level that you can increase, or how you can improve your equipment uptime, now you have two leading indicators that can affect the overall water protection.
Okay. The OKR, he explained, stands for Objective and Knowledge Results. So, question: leading indicators and objective and knowledge results. Does that mean the same purpose, same thing?
Again, it could be if they are defined similarly, because as the example that I said, if those leading indicators or the OKR are lined up with a particular objective in a proactive and influential meaning, then they are the same. But if they're just proactive but no influential, they're not the same.
Okay, thank you. All right, so another one here. Carl asks, does Dr. Ciudad see the cost of quality as a leading indicator? The cost of good quality as a leading indicator.
Yeah, again, it could be if the way that you define what your objective is. So the cost of good quality, if you benchmark, let's say, a company similar to yours or close to it, and that company spend twice as much as you do in the cost of good quality, then you ask yourself, well, I'm really good compared to that company. Or you can say proactively, you can say, what is my cost of good quality compared to volume of sales? And then you look for the relationship on how can you minimize the cost of good quality. Let's say you can look at the appraisal cost. Are you spending too much money in appraisal, or what can you do better to continue having the good performance, but using less people or less resources?
Okay, well, very good. We've had a couple of people mention book recommendations. Unfortunately, they're not going to all. They only go, we don't have, everybody can't chat to everybody. But one of the books mentioned is Principles of Quality Costs. I want to remind everybody that I'm the editor of the current version of that book. So you'll find it under Douglas Wood. You'll find it as also an earlier version by Jack Campanella. Jack did the third edition. I did the fourth one. All right. So another one here. What is more important, questioning the data or having data source accountability? Is getting the data from the process owner reliable? That's what they meant by data source accountability.
I question the data even from the person who gives me the data, because sometimes in my experience, people move, people change, people have different opportunities, and they move. Or even the person that is collecting the data as a resource, they might not be questioning the data. It might just be a task for her or for him. I want the data to be reliable and withstand questioning. It has to, for the data to be reliable. It has to withstand questioning. If you ask one question, let's say if I use the 5 why is this like this? Why is it like that? And on the second why, the person, I don't know, I just got it from Mary, and Mary is in the second shift. Then I start having bad feelings about that data. So that's a personal response. You might not think the same way I am, but I will suggest you to once in a while question the data, do your 5 whys in there until you feel comfortable. If you are comfortable, then the data becomes information, and more important, becomes knowledge, because you trust the data, you believe in the data, in the information, and you can start making decisions. And your decision will be close to 100% correct.
Okay. I do have a question here, though. You have the survey. Shall we send all participants the survey link in the chat window?
I say because I still have to run some tests, but I feel comfortable that yes, let's do it.
Okay. So there's a survey link now in the chat window. You may copy and paste that and put it in a document to keep. And take the survey from that. We wanted to make sure everybody had a chance to do that. Thank you, Grace, for asking that question.
Yeah, thank you.
So, we will also put that link in the email that goes out after this. We've got one more question here. I know it's a little after 6, but or
no
top of the
problem,
hour.
I
So,
appreciate it.
all right. So, well, okay. Related to the link, Ricardo says, what software are you using for your survey?
I'm using Surveil.
Surveil. Okay, it's in the link. Okay, and Arturo asks a question. What about an indicator to measure employee satisfaction? He says how to measure it, but I think in the context of this discussion, employee satisfaction is that a leading indicator even?
Well, it could be, again, going back to the definition, if employee satisfaction have a happier employee, an engaged employee, an employee that come to work with their brain and ready to add ideas and solve problems, it will be a great leading indicator because you set up a baseline. If the employee start going down, then it tells you that something is happening. And then it's an issue of finding out what it is. So it could be, again, it's just how do you define it.
Good point. Okay, another question about cost of quality. In which category can we include employee hiring and training costs? I think I have an opinion on that, having written a book here. But yeah, what do you think?
You wrote the book.
What do you think?
No, go ahead. Like you wrote the book.
Oh, okay. Okay, employee hiring and training. Well, employee hiring is something you do all the time. Okay, so that's sort of a cost of doing business. That's not really a cost of quality. Now, training costs, on the other hand, I mean, training. Why do you train people? You train people so that they don't make mistakes. I would call that prevention. What do you think?
Right. Having the right capabilities in the right job makes a big difference, not only to the company, but to the consumer, because it lowers the rework, lowers the rejects, affects employee happiness, to going back to the other question, because the employee is engaged, has the right training, feels comfortable, and that's a good job, the better job that can be done.
Mm-hmm. You know, I think for people who are struggling to sort out their costs into categories, I tell them, so what is the purpose of this expenditure? Why are you doing it? That will help you understand whether it's a, prevention or an appraisal, or if you're just cleaning up a mess, which of course would be a failure cost.
So, here I went back to the appraisal cost. There are several examples of appraisal costs and prevention costs, and also internal failure costs. So all of those are already in the bucket. So you already have identified those on the overall model. The task for people is to go in there and see if we have good data on those, get a Pareto, and attack the first 2 or 3 of the Pareto, and figure out if you really found the root cause, and kind of figure out to get some leading indicators so they don't return to be a tremendous cost to the company, because that's the best way to not only reduce costs, but improve delivery, improve consumer satisfaction, and protect the brand.
Yeah. Naheem asks a follow-on. He says, if a new technology or process is implemented, it will involve training to maintain quality. Is that not true? And he's right. I mean, look, training when you change a process is an essential thing. I mean, you can't leave it out. There's an interesting quote in here from Keith. He quotes H. James Harrington and Ernst & Young, and the quote says, "In reality, there seems to be little correlation between employee and customer satisfaction and organization performance." Which that sounds like Mr. Harrington. He can be a bit of a negative Nelly. I think, what do you think that quote represents?
Well, Doug, can I answer the question to the person in a different way when he says about you got new technology in there and you need to train them?
Please answer that.
There is something called, and I advise if people are interested in this webinar, there's something called the socio-technical theory. It's a fancy name for really understanding how technology and the human being interact. A typical example is when you go roll out an implementation of Oracle or SAP, and you just teach the people about Oracle or SAP, and the people kind of like, well, I just need to learn this, but they are not engaged to it, and the next thing you know, the people who are teaching that, they leave and they go back to use spreadsheets. And then they say, Oracle or SAP doesn't work, and then all of a sudden people are not using it because they're not loading it. Well, because the socio-technical theory says you don't only need to teach technology, but you need to develop the people side of technology. And they both need to interact. They don't need to teach the people about how to use the technology, how it can make that better, and trying to bring those two together so we are successful. There's a whole theory about it, and I see it happening often. Like all the stuff that I show you about technology in the lab, technology in manufacturing. If you don't approach both sides, the human side and technology as a whole, chances are you will have problems or serious problems because you focus too much on the technology.
It's kind of like training halfway, isn't it?
Right, but when you're dealing with humans, you know how complicated we are.
This is true.
It's you can get in trouble real quick if you don't address this human side.
Yeah.
Human factor. It's always important. I'm even though I have a degree in technology, I also have a degree in management, and trying to look at both always.
Well, you can't. You gotta have people in your company if you expect to get anything done. Okay, so we've kind of run out of time, folks, and I know there's some really good questions in here. I'll be providing these questions to Dr. Ciudad, and you will get his email address in an email in 2 days. That email address is not only good for you to ask more questions, but it's also going to be good for you to request PDF copies of this presentation. Is that right?
Yes.
Okay. And so we're going to kind of wind up here a little bit. I'm going to pause, stop the recording here, and then we'll do our closing.